the laws? Swati,
Yes, ma'am.
tell me.
Law of conservation of energy,
Ah,
law of conservation of linear momentum,
mm,
law of conservation of angular momentum, and law of conservation of charge.
very good. So these are all the different conservation laws. By using applying this, we can understand the natural phenomena, the facts, whatever we have experimented, everything. What are all the facts? Everything. To understand that, we need to have an idea about these laws, right? But the other entity which is essential now here to understand the phenomena, nature and natural phenomena, is what is called measurement. Measurement. See, yeah, the second, the conservation laws, the first law, what is energy is conserved. Therefore, one physical quantity which is coming here is energy. Okay, so energy is conserved. How to realize that energy is conserved? How to realize the validity of that statement? Okay, then next one, conservation of angular momentum. In the absence of an external force, linear momentum is constant. So, in the absence of external force, the linear momentum means it is nothing but P, that is equal to M into MV. Change in linear momentum is constant, that is M into V. Initial momentum is equal to the final momentum. So, for that, you need to have an idea about mass of the body, initial velocity, final velocity. Okay, so everything you need to have an idea about it, right? Then, and the next one is conservation of angular momentum. In the absence of an external torque, the angular momentum I omega is a constant. So here also we need to have an idea about angular momentum, that is I, moment of inertia, omega, etc., etc. So only if you have some idea about these quantities, they are called physical quantities. Anyhow, I'll tell you later. Therefore, quantities, only then you can, yeah, these laws are very important. Okay, then you only then you can realize the importance, and you can realize the importance of those laws. Okay, how it is useful in understanding the nature and natural phenomena. Therefore, how to the validity, how, see, how to understand this only by what is called the measurement. Unless you measure P, unless you measure M, V, I, omega, you cannot realize the importance of that conservation principles, how essential they are. Okay, for that you need to go for measurement. Okay, so a very, very important thing. Okay, let me give you one more example. You know very well, if you are if you are from certain height, okay, you are dropping a stone. So you know very well, because of gravity, that is nature, because of gravity, the stone falls down. Okay, when it is dropped. Okay, therefore, when it is falling down. Now, what are all the questions? See, that is a very simplest phenomena that you can take. Okay, everyone, even layman knows. Once you are dropping a stone, even you are leaving the stone, definitely at a two-story building, you are from there, you are leaving a very small ball. Okay, when you are leaving that ball, definitely you know very well, you expect that ball to come down only. Nobody can expect that to go up when you are dropping. I'm telling, when you are dropping. Therefore, which means that the principle involved here nothing but it is gravity. Okay, because of gravity, the ball comes down. That is known. Whether then even the layman knows about it, no, though it is a nature, natural phenomena. So, what is the principle underlying principle? They don't know, but they know very well this fact. What is that? The ball is going to come down. Okay, okay, that is no. Okay, but for that, to understand that phenomena better, okay, falling off a ball from two-story building. Okay, therefore that is a very simplest phenomena. But to understand that phenomena better, you need to have so many datas. What are all the data? What are all the data required here? What is the time taken by the ball to reach the ground? Number one. While it is traveling, whether the velocity is constant. If the velocity is changing, then what is the acceleration of the ball? Okay. Therefore, what is the height from which it is dropped? Okay. Whether the time depends on the height, and you can even whether the time taken by the ball to reach the ground depends on the mass of the body. Okay. Therefore, see how many questions are arising here. Okay. Therefore, whether the time and height depends whether time of fall, time of reaching depends on the height. So many things are there, whether it depends on mass. Okay. Therefore, see, simplest phenomena, to understand that phenomena, you need to have so many factors, so many data. Okay, so what other acceleration you want? You want the velocity. When it is dropped, what is the velocity? When it is reaching the ground, what is the velocity? Okay, and what is the time taken? So many things are here. So falling of a ball needs to be, if you understand that, okay, you need so many data here. So how to get the data? Only by measuring, only by measurement. Only you measure that, you will come to know, yes, the body is accelerated. When I am dropping the ball, that is equal to velocity is 0, just and dropping. Therefore, that time 0. Okay, what is as the body is accelerated? What is acceleration? Acceleration due to gravity, 9.8 meter per second squared. And the time only by measuring, but different heights you have to go and you have to drop it. And what is the time taken to reach the ground? You have to measure. Only then you will come to know, yes, time of fall depends very much on the height from where it is dropped. Okay, so how many? See, that which means that it requires a lot of data to understand the phenomena, the very simplest phenomena. Okay, so which means that much essential is our measurement here. So that is why the importance of measurement I'm telling. Okay, so now therefore I think you have understood why we are going for measurement. To understand physics better, measurement and physics is inseparable. Okay, therefore now let us go for now once understanding the need of what is here now what we're discussing is need of measurement. The need for measurement, you can say. Whether you have understood why we need, children? Whether you have understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes,
So
ma'am.
now physical quantity. Now let us go for what is a physical quantity. See, physical quantity as such, you know, we are using it. Okay, all the see force, momentum, everything. It is a physical quantity. So how to define a physical quantity? A quantity that can be measured. A quantity that can be measured. That is number one. And in terms of which laws of physics can be described. All the laws of physics can be described. Okay, so that is what is called physical quantity. What is a physical quantity? A quantity that can be measured and in terms of which laws of physics can be described perfectly, completely. Okay, so that is what is called physical quantity. Can you give example for physical quantity now?
Time, force, speed, distance.
Yeah, whichever is measurable. Okay, so everything is coming under physical quantity. Okay, right. Now, as I told you, a physical quantity means definitely the quantity that can be measured. Okay, for measuring a physical quantity, what are all the things required? Okay, for example, I am taking, see, a ribbon. Okay, let me have a ribbon of some length. Okay, 4 meter approximately, right? Okay, now listen, it is a ribbon. Now therefore length, which quantity am I measuring here is length. The physical quantity what I am measuring here is length. Okay, therefore I can write length that is equal to length of ribbon. What is the length of ribbon? Okay, length of ribbon. Okay. I am giving the length of ribbon as, okay, what is the length of the ribbon? Okay, I'm telling it. That is 4. 4. Whether it is complete?
No.
No. What is required here?
Meter. Unit.
Meter. Only then you get 4. Means what is 4? Okay. So, length of the ribbon means you need to give 4 meter. Okay. Then it is complete. Are you following? Therefore, length is a physical quantity. So, to represent a physical quantity, if you are measuring how to represent a length of the ribbon, if you want to give, you need to have 2 factors here. Number 1 is what is called the numerical value. Okay. And number 2 is what is the size of the unit. What is the unit? Are you following? Therefore, if I represent this length, physical quantity in general, so I am giving you example here. In general, how to represent a physical quantity? Let me represent a physical quantity by Q. See, I have given you an example with respect to length. So, in general, if I want to represent, so physical quantity is considered as Q. That is equal to how to represent 4 meter. I told you, 4 meter. 4 is a number. So, numerical, therefore, N. And what is meter here? Meter is a unit. Therefore, NU. Okay. Therefore, length of the ribbon, that is nothing but that is equal to NU. Okay. Therefore, now just like that, see, length that is equal to 4 meter is fine. Very good. So, we have represented the physical quantity properly. See, for example, if both are very much required, see, length of the ribbon that is equal to meter. If I write that one, then also it is incomplete. What meter? How much meter? Immediately the question arises. Okay. Therefore, N is the numerical, that number is very important. Like that, what is important here? The unit is also very important. So, without both, no, you cannot completely represent a physical quantity, length. Are you following when you are measuring? So, both are equally important. Just number means lot of question arises for whether it is centimeter, millimeter, decameter, nanometer, okay, femtometer, so many. So, what is that? So 4, which means that it is ambiguous. It is not at all complete. It is not wrong actually. 4 means it is wrong. What is it? Okay. That is why unit plays a very important here. That is why I just want to give you unit. What is the importance of unit here? Therefore, next one is, what is that? Without number also, if you are giving the unit, that is also incomplete. So that is not right. Now, one more thing, what I want, L is equal to 4 meter, fine. I can represent the same thing, okay, that is nothing but 400 centimeter also I can write, okay. Therefore, that is also same, the value is not at all changed, okay. Therefore, here length is equal to 4 meter, that is nothing but 400 centimeter. Therefore, that means that, see, here, a same physical quantity can be expressed in terms of different units. Okay. But while describing, the number will change. If, see, the unit also big unit and small units. If you see, M is considered the size of the unit. Size of the unit, a meter is, you know very well, it is a larger unit when compared to centimeter. That is a well-known fact, right? Therefore, if the unit size is more, then the number will be less. N is more, okay, the number. Then unit size will be definitely less, correct? 4 meter and 400 centimeter. Size of centimeter is less when compared to meter. But the number here is more. Are you following? Is it clear? Therefore, now hope L is equal to 4 meter, that is equal to 400 centimeter. Same physical quantity can be represented in terms of different units. Smaller the unit, more is the number. Okay, and that is very, very important. Okay, therefore, now how to generalize that? Therefore, here this Q, the physical quantity Q, that is nothing but if I want to represent terms of different units, therefore N1 U1. But one very important thing. Okay, listen, I have before coming. See, L is equal to 4 meters equal to 400 centimeter. Okay, you cannot say that that is nothing but, okay, how many millimeters, ma? If I cannot say that it is nothing but 4,000, you cannot listen to me why I am telling here. See, 4,000 kilogram. Whether there is any meaning in it? Whether any meaning?
No, ma'am.
Oh. So every physical quantity, which means that every physical quantity has its own unit. One, you have to represent that physical quantity only with respect to that unit. Okay. Therefore, there are set of units which are allowed for a given physical quantity. Okay. So that is very important. Okay. Therefore, N1 U1 that is equal to N2 U2. What is N1 here with respect to this? 4 meters is equal to 400. Q here, what is that? L. Physical quantity, what we have measured here, taken here, example is L. And that is equal to length is 4 meter. That is nothing but 400 centimeter. Are you following, children? Is it clear? Okay. Therefore, this is that gives you the importance. See, what are all the things which is required in if you need to measure a physical quantity? Okay, very important how to represent a physical quantity. There are two things required. One is the number and another one is a unit. Okay, right. With this, now next we are going to fundamental units and derived units. Fundamental. Before going to that, let me go for fundamental. Let me go for deriving fundamental physical quantity is derived. Is you can say even we can classify the physical quantities.
Ma'am, base unit.
Yeah, in terms of the physical quantities can be represented in terms of, okay, can be divided into fundamental physical quantity. Physical quantity, I'm not coming to unit. Fundamental physical quantity and derived physical quantity. What do you mean by it first? Okay. Therefore, the physical quantities are divided into fundamental and derived physical quantities. What are fundamental physical quantities? The fundamental physical quantities are quantities which are independent of any other physical quantities for its complete representation, complete description. Okay, what is a fundamental physical quantity? Quantity means it is self-sufficient. It can describe itself. Okay, there is no need for any other physical quantity to describe the fundamental physical quantity. It is self-sufficient.
And can you repeat the definition?
See, fundamental physical quantities are the physical quantities which are independent of any other physical quantities for its complete description. Okay, if you want to represent the fundamental physical quantity, there is no need to get the help from some other physical quantity. For example, you see, what are fundamental physics in mechanics? In mechanics, okay, mechanics means what we are studying here. Laws of motion, what and all. See, mechanics, it deals with, I think, Newton's laws of motion, gravitation, everything is there. I think we have seen classical mechanics, quantum mechanics, everything we have seen. In mechanics, what are all the very, very usually what are the fundamental quantities what we come across are length, definitely. Okay. Then one-dimensional motion, two-dimensional motion, okay, three-dimensional motion, laws of motion, energy, power, Okay, all these things, they come under what is that? Mechanics. So in mechanics, what are all the fundamental physical quantity we come across? That they are length, okay, mass, and time. Okay, therefore in mechanics we treat these three as basic or fundamental quantities. Okay, therefore now why are they fundamental? See, for representing length of the ribbon, okay, whether you need to take the help of mass here, whether it depends, whether length of the ribbon depends on mass. No.
No, ma'am.
Okay. Whether it depends on any other physical quantity, length of the ribbon I want, that's all. That is a physical quantity what I need. Okay, it is independent. If I want to describe length, there is no need for any other physical quantity to represent length. It is self-sufficient. It can describe itself completely. Are you following? That is why it is what is called fundamental physical quantities. Okay, next one now we are dealing only with mechanics, right? Therefore, derived physical quantity. Derived physical quantity means quantities I have to take. Derived physical quantities. What are they? They cannot be completely described. They are independent. You cannot say fundamental quantities are independent of any other physical quantity. Okay, they can represent, they can describe themselves, okay, completely. But derived physical quantities, you cannot say they are independent physical quantities. They depend somehow on the fundamental quantities, physical quantities, for their complete description. Okay, if you want, for example, derived physical quantities, very simple. You can say, what is that? Area. Okay, area of a rectangle. Therefore, you can say it is length into breadth. Okay, therefore, length is a physical quantity coming under length, physical quantity length. Breadth also, it is also what is the length only now? That is also, which it is nothing but length. Okay, so here it comes under breadth is also coming under the physical quantity. What is the length? Are you following? Therefore, which means that area depends very much on the physical quantity called length. Okay, now next one can be about speed. Speed means it is distance covered by time. Correct? So distance covered by time means you need to, the speed, to represent speed properly, it depends, you need to have two data here. Two physical quantities here. Distance, that is length. Distance means length, and time. So, it actually, to represent speed, we need to take help from two other fundamental physical quantities, what is called length and time. Okay, right. Density. Density means mass by volume. Mass by volume. Therefore, your volume once again, what is that? L. See, if there is a cube means L cube. Okay. Therefore, what is the volume? Volume is nothing but cube. What is the volume of the cube, ma?
T cube.
I think you have idea. L. Therefore, it is volume is L cube. So, which means that it depends very much on length, volume. The other one, mass. It depends, density depends on two factors. One is, what is the mass? The fundamental physical quantity called mass. The other one is what is called length. So, which means that is why I just want to tell you, derived physical quantities means they depend on fundamental physical quantities for its complete description. Hope you are following, children. So, without fundamental physical quantity, you cannot express the derived physical quantity. Okay, but fundamental physical quantity means they are self-sufficient. That's all. Is it clear? Therefore, with this, let us go for very simple now. What are fundamental units and what are derived units? Therefore, fundamental units or basic units. Now, therefore, units I can divide with respect to the same. What is that? The concept is same. What is that? Here, physical quantities are divided into fundamental and derived physical quantity. Like that, units you can say it is fundamental units, and another one is derived units. Derived units. Okay, therefore, in mechanics, what are fundamental units? Fundamental units are, what is that? The units which do not require any other, what is a unit for its complete description. Okay, they are independent of any other unit. Okay, therefore, you can even say fundamental units are nothing but units of fundamental physical quantities. What are, is it clear? They are highly independent. Therefore, why
Can you repeat?
fundamental units? Fundamental units are actually basic units which are actually independent of any other units. Okay, for its complete description. Okay, you can say even the fundamental units are units of fundamental physical quantities. You know, fundamental physical quantities are completely independent physical quantities. I told you, just now I have explained. Therefore, units of fundamental physical quantities are fundamental units in mechanics. Therefore, what are all the units you can say? See, fundamental units means length, unit of length, meter, unit of mass, kilogram, unit of time, second. So these are, okay, coming under fundamental units. Unit, okay, like the derived units. Derived units, you tell me, is it clear? Hope you are following, children. Is it clear? Is it clear? You have,
Yes, ma'am.
Yes, ma'am.
okay. Therefore, now here meter, it is a meter, okay, and number 2 is kilogram and kilogram. Okay, number 3 is second or let it be second, hour, minute, whatever is the case. Therefore, these are fundamental units. Derived units means unit of area. Unit of area. What is that? Meter square. Okay, density. For density, what is the unit? Kilogram, mass by volume, no? Kilogram divided by meter cube. So, which takes help from, what is the fundamental unit? Which are the unit? Kilogram and meter. So, kilogram per meter cube is what is the unit of density. Are you following, children? Is it clear? Okay, like that you can give so many force. Even force is, what is force? Force is nothing but m into a. Okay, therefore m into a. Acceleration. Acceleration is nothing but velocity divided by speed, velocity divided by time. Change in velocity divided by time. Therefore, once again depends on meter and second. Acceleration is a derived physical quantity. Therefore, unit of acceleration, meter per second square. Okay, that is also a derived physical quantity. Therefore, what is the unit of force? M into A. Therefore, kilogram meter per second squared. Okay, A is meter per second squared and kilogram M. Therefore, that is also what is called coming under derived physical quantity. Hope you are following, children. Okay, shall we go to the next one? Next topic? Okay.
Yes, ma'am.
Now, let us go. I think you people are studying this slightly in chemistry also now. Sure? Are you?
Yes, ma'am. Yes, ma'am.
Right. Now let us go for systems of unit. Systems of unit. Units. Okay. See, there are some complete set of units, both for fundamental and derived units. Okay, for every physical, for all kinds of physical quantities, you can say. A set of units are allowed. Okay, for fundamental and for representing for all kinds of physical quantities. Therefore, what are all the sets? They are given under some, what is that, system. It is termed as fundamental common system of units. Okay, one full set is, one system has, for example, fundamental mechanics. I told, once again we are dealing only with here mechanics. Mechanics means what are all the fundamental physical quantities, means you can say length, mass and time. Okay, so length, mass and time, what, there are different sets of units are allowed, okay, for length, mass and time. Different sets of units. Okay, what are those units? Now we are going to see. Number one, listen. The very old units, British system of units actually, okay, that is FPS system. The FPS system of unit. What do you mean by FPS system? See, FPS system means it is length is measured by foot. Okay, foot. That is, foot is, what is that? Length measure. Length is measured by foot. Okay, and mass is measured with a unit pound. Okay, and time, of course, it is second. Okay, therefore, this system, that is why this FPS system is, it can give what a set of units for different physical quantities. Okay, therefore, what is that? Only the fundamental physical, with respect to the fundamental physical quantities in mechanics, I can say that it is FPS system. What is that? Length is measured by foot, mass by pound, and time by second. So this is what is called FPS system. After that, we will see the validity of the system afterwards, how it is used, whether it is very much useful, what are all the limitations, everything we'll see. First, we'll see what are all the, I'll list the system now. FPS system. Next one is CGS system. What do you mean by CGS system? Length is everything with respect to fundamental physical quantities in mechanics. Length, mass, time only. With respect to that only, the system name is given. Okay, CGS system. CGS system means, you can say it is centimeter. Length is given by centimeter. Okay, and mass, gram, and of course, mostly time will be in second only, whatever be the system. Okay, second. Then, so third one. Third one is what is called MKS system. Okay, what is MKS system? MKS system means mass. If I want to represent it here in the system, mass is measured in terms of meter, and length. Length is measured in terms of meter. Mass is measured in terms of kilogram, and time in terms of second. Okay, M means meter. Okay, that is why M means meter. That is, length is measured in terms of meter, mass in terms of kilogram, and time in terms of second. Okay, therefore, here CGS and MKS systems are called metric systems. Why is it called metric systems? Means you can say very easy to convert. See, your multiples and submultiples, whatever you want to represent, it will be represented only in terms of you can say powers of 10. Powers of 10. See, you know that 1 meter or 1 meter, it is nothing but 100 centimeter. Therefore, it is 10 squared centimeter. Correct? Therefore, which means that very simple. Meter means it is MKS system. Centimeter, CGS system. Therefore, 1 meter is nothing but 10 square centimeter. So, very easy for you to convert, you know. It's very, very simple for you to convert. So, you can convert one system to another system very easily. Why? Because either you have to multiply with a multiply, divide, okay, by powers of 10. By powers of 10. Or 1 centimeter is nothing but 1 centimeter is nothing but 1 by 100 meter. Therefore, 10 power minus 2 meter. 1 centimeter. Are you following? Therefore, here either you have to multiply, that is powers of 10 has to be either multiplied or divided, so that you can convert one system to other system very, very easily. But CGS system is a small, very small unit system. Okay. Therefore, that is why the CGS system and MKS system, they are called as metric or system or decimal system. Okay. But coming to FPS system, but see, that is fine. CGS, MKS, very simple, very easily you can convert from one to another just by multiplying or dividing to the powers of 10. That's it. Very simple. Okay. But in spite of that CGS system, no, if you compare CGS and MKS, CGS system is not that convenient. Drawback of CGS system, if you say, na. Why? Because you see, what is the unit of length is centimeter, na? So it is inconveniently small, very, very small unit. Very small unit. With respect to that, you cannot see gram. Gram is also very, very small. Okay. So which means that it is not that very, very practical. It is not a practical unit. Okay. Centimeter, gram. Why? Because it is inconveniently small to handle. Okay. That is why this is one of the very the drawback of CGS. Though the other things are okay, conversion, everything easy to convert. This is also a metric system, but this is because of very tiny system of unit, so it is inconvenient to handle. But MKS system, so MKS system means you can say advantage of MKS system are okay, a convenient size. Okay. Therefore, very convenient. Meter, kilogram. Okay. The everything second. Why second is also convenient unit only. You cannot say. Okay. Therefore, which means that is why MKS system is highly popular. Okay. But it is convenient MKS system. But FPS, you come to FPS system. See, lot of limitations. It is not at all a popular system of unit. Maybe it is even still British people are using. Okay. So why? Because you know 1 foot. Okay. 1 foot is, because a foot is a unit for length. Na? 1 foot if you take, okay. Here you see very how nice. 1 meter is equal to 100 centimeter. How nice. It is very easy for you to multiply, divide, to convert one system to another system. But here 1 foot means, if I want to represent in terms of meter, you just imagine 0.3048 meter. 3048 meter. Just you see how inconvenient for you. Can you see if I'm asking you to convert, okay, 5 centimeter to meter? What is 5? Can you convert 5 centimeter to meter? Tell me, hurry up.
Yes, ma'am.
Tell me.
0.05 meter.
0.05 meter. What did you do for that?
Divide
by 100.
Divide by 100.
Divide by 100. Very easy for you, no? Okay. Now, I am asking you. Okay. Can you convert 1 meter to foot? How many foots are there in 1 meter? Can you give immediately?
3.2.
How many foot? 1 foot is equal to 0.3048 meter. Therefore, 1 meter is equal to 1 foot divided by 0.3048. Na? Are you following?
Yes, ma'am.
Yes, ma'am.
Okay. Can you give me the answer? Immediately you give.
I'm 3.280.
Okay. Who is it? You have calculator with you?
And 3.280.
Calculator is there, I know. Okay. So it is not that easy for you. Okay. This is okay. This because we know. Okay. Okay. I am asking you. Convert 2.8 meter to foot. Now you tell me. Listen, why I am telling, whether you are able to understand what is a limitation here, what is a disadvantage. Okay, I'm not asking you to, because you see, very easy for you to convert CGS to MKS, MKS to CGS and all, but it is not that easy for you to convert here. Okay, 2.8 meter, you convert it to foot means it is very difficult now. Okay, are you following? Are you following?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This into 2.8. So very difficult. So it is not at all popular. Why? Because you cannot, just like that you cannot convert. You should have a calculator with you. Okay, for that. Okay, so that is why. Next one, pound. Okay, 1 pound. 1 pound, what is the symbol is 1 LB. LB is what is called pound. Okay. So 1 pound, if you are telling, if you are, it is also, see, you see the value in meter. If I want to get 1 pound is equal to 0.4536 kilogram. 0.4536. It is one. This much of kilogram is nothing but 1 pound. Even British people are using pounds nowadays. Okay, even now. So 0.4536 kilograms. So how inconvenient it is. Whether it is easy for you to convert 5 lb to gram. Convert 5 lb to gram. Is it easy?
No, ma'am.
No, ma'am.
You have to take some time to calculate. Okay, but it is not that easy as you convert 5 kilogram to gram. So very easy. Okay, but it is pound, converting pound to kilogram and kilogram to pound to gram. Everything is very, very difficult. Okay, so inconvenient multiple it is having. It is having inconvenient multiple and submultiples are involved. Okay, while if you want to convert from one system to another system, that is why it is not a popular unit. Okay, therefore, even the MKS system can be extended. Even one more this one MKS system can be extended to electricity also. Not only mechanics and electricity, if you want, na MKSA system. Electricity. Therefore, A is for, what is that? What is A stand for?
Ampere.
Ampere.
Okay, now, right. So, knowing these things, now we are going to very important system of unit, fourth unit here. That is what is called international system of unit. International system of units, system internationally, it is called SI system. Okay, so which system is accepted internationally? Okay, so if you want to international for all your international dealings, we use only what is that SI system of unit. Okay, therefore, why SI system of unit is actually nothing but essentially MKS system only, system of unit, but it is also called, it is a you can say modification, that is, it is a modification done in MKS system of unit. That is called rationalized. It is called, okay, you can even say it is nothing but rationalized MKS system. Okay, therefore, see, you know that in the case in physics, the rationalization is very much essential. Why? Because to obtain the different units of different physical quantities in every field of physics. Okay, therefore, but MKS system deals only with mass, length, time on MKS system. Okay, that can be used only in representing unit only in mechanics. But if you want to extend this to other fields also, other field of physics, okay, then SI system is coming to rescue. Okay, therefore maximum you can go only for MKSA. Okay, for MKS system. But rationalized MKS system means it can be, if you modified MKS system, it can be used for different used to represent the units of different physical, almost all the physical quantities in physics can be expressed in terms of what is a rationalized MKS system. Hope you are following. MKS system is meant only for MKS, that is only for mechanics, and a part of what is a current. Current is, it can be extended to even electricity. Okay, but if it is not the only field of physics, different fields of physics are there. Okay, therefore, how to represent the different physical quantities which we come across, for that only the extended a modified MKS system, rationalized MKS system we are using, that is what is called system internationally, and that is what is called internationally accepted system of unit. Therefore, here you have to go for what are all the because why is international system means, for example, I'll just give you one example. Okay, mass, if you mass of a body means kilogram, that is except in SI unit also it is just like MKS system only. Okay, length is meter, mass is kilogram, and time is second, right? Okay, so if you want to have some internationally, if you want to give data, okay, I think there is one mass of gold. Okay, I'm giving you an example, simple example. Okay, mass of gold means here in Tamil Nadu and all, no? Actually, I think you have idea how to represent 1 pound. Okay, 1 sovereign. 1 sovereign means that is equal to 8 grams. 8 gram of gold. It is not but 1 sovereign. Like, so it is 1 sovereign, okay, is nothing but 8 grams of gold. 1 sovereign of gold means. Like that in North India, I think you people are using tola, 1 tola, correct? I think you, North Indian children, 1 tola, that is nothing but 10 grams of gold. Okay, very simple. In our Tamil Nadu and all, we are using sovereign for measuring the mass of the gold, Okay, all the ornaments, we will be giving 2 sovereigns, 5 sovereigns, 10 sovereigns. But in North India, they give in terms of tola, 1, 2, 3 tolas like that. 1 tola is nothing but 10 grams of gold. I don't know how I am pronouncing. I don't know, but it is 10 grams of gold. Okay. So, listen to me. In our India only, South India is using 1 system of unit sovereign for mass and mass of gold. And North India is having some other system. Okay. So, you cannot use this unit if you want to represent something in international system. Okay, international system, if you want to send something, data, you cannot say that, what is that, 100 sovereigns of gold, means they will blink there. Are you following? So, you cannot, there are some system of units are allowed, okay, but they are called a system, international system. That only you have to use when we are representing with what is internationally, even not only internationally, here also. See, even North Indians, they don't know 1 sovereign. What is it? So, how to avoid these things? Just by using only one system, what is called SI system. Even you know, nowadays, you know, length, South India, you know, if you are buying flowers, you know, Gajra, flowers, the children, they used to come one, they used to tell that one arm length, one moyam. Okay, when you are using jasmine, you are when you are purchasing, okay, 2 arm length of what is a jasmine flower. So when it is tied, okay, therefore to arm length. See what inconvenient and what uncertain unit arm length. See why arm length? Arm length differs from person to person. No? Okay, so one small child is coming to sell. Therefore, arm length for her will be very, very less. Okay, and therefore it changes from, for adult it will be different, for small children it will be different. So person to person the arm length will be different. Therefore, that cannot be what is a trusted unit of length. Okay, so that is why we should have a proper unit. That is why we are going for what is the international system of unit, what is called SI system. So now shall we go for fundamental? So this SI unit, now we are going to see, I think you would have studied in chemistry, anyhow I'll run here. Fundamental unit and supplementary unit in SI system, and fundamental and supplementary units on SI system. Okay, now I think you can recall, you would have studied in chemistry, fundamental physical quantities. Fundamental physical quantities under SI system, if you say number 1 is mass. Okay, what is the unit here? Fundamental unit, SI unit. Fundamental unit here, SI unit is, you know that, kilogram. Okay, simple as this. Then number 2, length. Length is L. Okay, therefore it is meter. 3, time, second. Everything comes under SI system, small s. Okay, then 4th, apart from that. See, I told you rationalized MKS system is what is called SI. Okay, therefore why? Because with the SI system you can give unit for different physical quantities we come across in physics, I told you. That is why here I am going to give you extra unit. Here you see temperature. Temperature you cannot represent in MK system. Okay, so theta, that is Kelvin. Right, then 5, current, electric current. So electric current, how to represent? I. Okay, what is the unit here is ampere. Okay, right. Now next one, electric current. I think next one, can you give me? You would have studied electricity. Luminous. Luminous intensity. That is actually luminous intensity is CD. One day we will say. Okay, candela, CD. Then matter, amount of matter, quantity of matter. Quantity of matter is other quantity, other physical quantity. So this and all you cannot measure in MK system. That is why. Okay. See, electric current is okay. MKSA. Temperature, luminous intensity, quantity of matter. These are all the fundamental quantities that we come across. Okay, that is mole. Okay, therefore, how to represent mole? These are all main fundamental units. Next one is what is called supplementary units. Supplementary units, can you tell me?
Ma'am, plane angle.
Ah, so,
Radian.
yeah, sorry, one is plane angle. Plane angle, this is a quantity. Physical quantity is plane angle. How to, what is a unit is radian. Okay, radian. Number 2 is solid angle. What is plane angle, solid angle? You have idea? Can you give? You have given steradian is unit, SR. Okay, but what is plane angle? What is solid angle? You have idea? Yes.
Ma'am, in solid angle, we will measure we will measure 3-dimensional angle.
Yeah, 3D angle. It is 3D, and plane angle means plane itself.
2D.
2D. 2D angle. Okay. Therefore, a circle is there, and if I want to measure the angle between these two, that is here, this is nothing but plane angle. Okay, but a sphere is there. A sphere. See, a sphere means then it is solid angle. Then if I want to find out the angle at the center, then it becomes solid angle. Okay, that we will see. Let me. What is the time? 10:08. Okay. Now I'll stop here. So that will conclude tomorrow. We will start with supplementary.